Hello everyone, my name is Tanmay Kokare and I am currently pursuing my third year in Electronics and Telecommunication Engineering at Government College of Engineering. Karachi. In this video, I will be walking you through the internship project I completed under the Emertxe Embedded System internship program. My project is titled Washing Machine Controller using PIC16F877A. This project is designed using embedded C and simulated in the real-time use tools like MPLAB XPD and PICSimLab. The aim is to replicate the behavior of real-world washing machines with interactive user and control. Now, talking about the internship overview, the immersive internship is focused on practical exposure to embedded systems. It covered areas such as embedded C, microcontroller fundamentals, state machines, timers, and peripheral interfaces. We know the peripherals like CLCD, digital keypad, buzzers, fan, etc. that we can see in the microcontrollers. Over the course of 4 weeks, I was trained in simulation-based project development and real-time debugging techniques. This internship bridged the gap between academic theory and applied engineering. I gained experience working with MPLAB X IDE and X8 compiler for embedded code development, and PICSimLab for simulation and testing of the microcontroller environment. Designing modular code using interrupts, state transitions, and hardware level input and output. This background allowed me to confidently build the washing machine controller as my capstone project. Now, talking about the project goals. My main learning objectives were to understand and apply state machine logic for real world appliance simulation, to practice interrupt based timing and control using timer tools, to interface input peripherals like digital keypads, output devices like 16x4 LCD and buzzer, to debug and test using virtual simulation platforms without physical hardware, to implement a modular and readable code base that could be extended or reused for future projects. These goals were made through guided mentorship and the structured project building at Emertxe. Now, talking about the Emertxe internship is of 1 month. The first 15 days was focused mainly on the base, that is the embedded system from arrays, functions, pointers, etc. That all are covered in the 15 days under the C module. The next 15 days is all about the embedded system, the introduction of embedded system, types of embedded system, categories of embedded system, and the basic functionality and the basic points that covered under the microcontroller, that is the introduction of microcontroller, hardware and von Neumann architecture, and the thorough introduction about all the peripherals that we're gonna use in that project, like washing machine controller, that the digital keypad, buzzer, fan, etc. Now, talking about the project overview. The objective of this project is to simulate a fully functional washing machine controller using the PIC16F877A microcontroller. It operates via 6 digital keypad with user feedback provided on 16 into 4 character LCD. The controller goes through various stages of washing program selection, water level selection, start stop, functional work cycle, wash to rinse, to spin, and program completion. The special functionalities include door status monitoring using SW1, audible alerts via buzzer RC1 ping, timer-based cycle management using ISR, user-guided transitions between screens, The design is simulated using PICSimLab to reflect real-time behavior. As we can see in the slide that the system overview, program selection, water selection starts, functional status completion. All this we can see on the demo part, that how we can switch from program selection to water level screen to stop screen, that usually we can see on our washing machines, like we know that brands like the Bosch, Godrej, which actively working on the washing machines development. This is the basic functionality that we have seen in the project. We can see in the project in the project demo. Now, block diagram of that project we can see on the slide. The hardware block diagram consists of digital keypad SW1 to SW6, 16:4 LCD display, which is connected to port D of the microcontroller for displaying status and prompts. Buzzer is connected to RC1 for sound alerts. A door switch SW1 on RD0. The PIC16F877A microcontroller as the brain of the system. This diagram shows how input flows from the keypad to controller, which processes logic and updates the LCD and buzzer accordingly. The entire setup is tested virtually within PICSimLab. This is the block diagram of the system. This is the digital keypad which is connected to port B of the PIC16F877A. The basic of the PIC16F877A is that it has five ports: A, B, C, D, E. Now, which is the 16:4 LCD display, we have used 16:4 character displays, that we can print the 16 characters on the four lines, print out on the LCD display, that we can print the instruction as well as data on that character display. Now, this is the main MPU, that is microcontroller, which governs and functions all these peripherals. This is buzzer, which is connected to RC1, that is port C of the microcontroller, and this is the door status SWN, which is work by pressing the switch 1 of the digital keypad. Now, what are the tools and the components that we have used in this project? Is basically separated via hardware and software. MPLAB XID used for code writing and debugging. X8 compiler converts C code into machine code for 16F877A. PICSimLab for virtual simulation of embedded system. Now, talking about the hardware components that we have used in the project, that is PIC16F877A, which is a 8-bit microcontroller, digital keypad, which can includes SWN1 to SW6 switches for all user inputs. The 16:4 character LCD, which is used to display outputs. Now the buzzer for door alerts and cycle completion tone. Software timer 2 plus ISR to create real-time display and countdown. All modules were programmed using embedded C and integrated in a modular format for ease of debugging and the state management. As we know that the embedded system is a combination of hardware plus software to do the specific. And the washing machine is a dominant and prominent example of the embedded system, which includes hardware like this and software like compiler, simulation tools, etc., to the specific task to wash clothes. Now, the what are the key features that we have added in that project is The controller simulates a complete washing cycle. The SW5 powers on the machine, triggering a boot animation. This all we can see in the project demo in the last part of our video. SW4 scrolls through 12 predefined washing programs. When we press the short press, then we can only scroll down the washing programs. When we press long to the SW4, it moves to the water level selection screen. User chooses a water labels using the same key and long press again to proceed. In the start stop screen, SW5 starts the washing cycle. SW6 pauses resumes ongoing cycle. During operation, timer 2 handles a 1 second countdown interval using ISR. The LCD updates for every stages that we can see in our regular washing machine like wash, rinse, spray, spin, etc. If SW1 is pressed during cycle, the system halts and displays door open with buzzer. At completion, LCD displays program is completed and buzzer sounds. These transitions ensures interactive control and simulate a real appliance workflow. Now, the state machine logic that we have implemented in the project is the project is built around the state machine with five primary stages like wash program screen, water level screen, start stop screen, function screen, completion screen. Default screen to scroll and choose the wash program. The water level screen is used to selection of water level like low, medium, high, etc. The start stop screen is used to decide the user to begin or pause the washing. Function screen. The entire process runs through wash, rinse, and spin with countdown. Completion screen. That is the last screen we can see on the in this project. That is used to display final alert and message. Each state is coded modularly and transitions only when specific inputs are detected. Example, short or long press, SW5, timer expired. This design simplifies the debugging and enhances maintainability. Now talking about the implementation highlights. The key technical implementation points. Timer 2 configured for 1 second ISRT. Global variable, which is remaining tile, declared via ISR. LCD is refreshed carefully using clear scheme before updates to avoid flicker. Keypad includes debouncing, short long press tracking, and input capture. Buzzer is activated conditionally, that is door alert or cycle complete. Door status SW1 is globally checked and halts operation when triggered. The entire system is developed using bottom-up approach, beginning with individual drivers like LCD keypad and integrating them into a top-level state-driven application. Now talking about the challenges we have faced during the project and the solution of that. First, that the timer is not updating properly. So we have fixed the ISR logic in that. Now the SW4 skipping screens improve long short press handling that I implemented in this project. Sometimes buzzer not responding. Then I corrected the port and reset up. Sometimes LCDs overlapping, that is, screens are overlapping on each other. So I added clear screen function, thus delay transitions. Now talking about the conclusion and the demo. This internship project taught me the complete life cycle of an embedded product from idea to design, coding, debugging, and testing. I developed confidence in handling hardware interactions virtually using state machines and creating a structured code base that could be extended or upgraded. Now I will be begin with simulation demonstration in PICSimLab, which includes power on controller using SW5, scroll and select program, choose water level and start washing, observe the wash, rinse, steam countdowns, simulate the door openings with SW1 and show alert. Finally, let the cycle complete and show the buzzer sound with LCD update. Now we can move to the demo part that we have seen on the PICSimLab. We can see the PICSimLab, that is, we have used the microcontroller PIC16F877A. Here we can choose the whatever microcontroller that we have to use. This is the port. We have used the Peak Genius board in this project. This is the file section. We have can see the load, reload, last, load hex file. We have to we can load the hex file in this section where the hex file is which is generated in the MPLAB X IDE, where we have written the code and executed successfully. We have already loaded the hex file of that project. Here the clock is where we have fixed at 20 megahertz. Now the LCD, which is HD44780 16 into 4 character LCD we have used. Now we can see there are switches, digital keypad, LCD ports, switches, fan, buzzer in this Exim lab. So this is the character LCD. The first screen is shown here. This is press key 5 to power on washing machine. We have to press the key 5 to power on the washing machine. Here are some here are we have implemented the digital keypad of 16 6 switches. Switch 1, switch 2, switch 3, switch 4, switch 5, switch 6, which are connected to port B. We have to press key 5 to start the washing machine. This is the powering on washing machine screen is implemented. Now the second screen is we have implemented, that is the animation screen of power on washing machine. Now the third screen, which is about the washing programs. We know that washing programs like daily, heavy, delicates. We know that we have to press the SW4 for short press duration to scroll down the washing programs. Yeah. We have implemented 12 washing programs. It is scrolling down when we press the SW4. Rinse plus dry, dry only, wash only, aqua store. And again, the daily heavy delicates. When we press long the SW4, it goes to the water level. It might sometimes the water level screen may be keep due to last long press to the SW4. So we can use the SW6. So again go to the water levels. These are the water levels we can see: auto, low, medium. We can scroll down these: medium, high, max. Again auto and low. There are 5 water levels we have included in this project. Again we can press the long press to the SW4 to go to the next. Now we have the SW5, SW6. Now we can start the washing machine. Now we can see the function wash, timer is updating, start and pause. We can pause this now by 6, start. Now program is completed and we have to remove the clothes. We can see that last screen of that. And when the SW1 is pressed, we get the door completion status and buzzer notification. Like when we press that, get buzzer notification and door completion screen that door is open. We have to please close. This is all about the project that we have completed in this. Thank you for watching my presentation. I am Tanmay Kokare. Please feel free to reach out with my question, with any question that you have arrived, and I appreciate your time and feedback. Thank you.